16. From the information provided, use cell notation to describe the following systems. And then we have letter A. So in this case, we have in one half cell, a solution of PT NO3 forms PT metal, while in the other half cell, we have copper metal, Cu metal, goes into Cu NO3 solution, while all solute concentrations are 1 molarity. All right, so it seems like we have half cells going on here. And when we're talking about half cells, we're talking about an oxidation reduction reaction. So one has to undergo oxidation and the other one has to undergo reduction. And we're going to use cell notation to describe what's going on here. Now, first off, I'm just going to kind of write a general equation for what's going on. So let's focus on the one half cell. They said that we had a starting solution. We had a solution of PTNO3 forms PT metal. So in this case, I'm just going to get straight to it. I'm going to say, okay, PT NO3 is going to form that PT metal. And if platinum PT is a metal, that means that it has to be in its solid form. Now, when we do oxidation and reduction, we only care about the elements that change oxidation states. So since they're talking to us here, and I don't see any nitrate, right? NO3 is nitrate. I don't see any nitrates over here. Chances are the nitrate is not going to be the one that is changing oxidation state. However, if we do break this compound down, and I break this into its ions, I will have PT and NO3. Now we can use those subscripts to find out what the ions are. There was 1 platinum and 2 nitrates. So this one crisscrosses up telling me that the nitrate was a -1, which is always the case. And the 2 crisscrosses up telling us that the platinum is a +2. Now they did say that this was in a solution. And if you are in a solution, you're going to be in aqueous, you're going to be in aqueous state in water. So if this is aqueous, that means that both of these are aqueous. And now we see that we have a platinum that is aqueous with a charge going into platinum that's a solid. That's something different. So in general now, we can write that this actually, the only thing that we care about is just the PT +2 aqueous going into the platinum solid. Now we're going to do the other half cell, kind of the same way. They said that in the other half cell, copper metal goes into a solution. So this is kind of vice versa. We're starting off with the metal, so that's the solid, copper, Cu, and it's going into the solution, Cu, NO3 They said that it was aqueous. Well, they said that it was a solution. That means that it's aqueous, right? So I know that if this is aqueous, this is going to break down into its 2 ions, the copper and the nitrate. If we use those same subscripts again, 1 copper for every 2 nitrates, the 1 crisscrosses up telling me that the nitrate is a -1, the 2 crisscrosses up telling me that the copper is a +2, and these are aqueous as well. And the only thing that changed in oxidation state was the copper being a solid to now having an actual charge of a +2. So those are the only things that I care about. I don't care about the nitrates. Okay. So now, let's discuss how we're going to bring this into a cell notation. Now, cell notation just means that we're basically going to use a schematic or a diagram. And the generalized cell notation looks like this. Okay, but it comes down to what's going on at the anode, which is always oxidation, and then what's going on at the cathode, which is always reduction. So you could always memorize this by knowing that anox is always first, and then red cat, reduction cathode. Keep in mind that, remember, oxidation always means that you lose electrons. You're always going to become more positive in number because electrons are negative. But if you're gaining electrons, that's what reduction is, you're going to become more negative because you're literally gaining negative charges. So all you got to do is just look at these charges in the upper right-hand corner. Platinum PT was a +2, and the platinum over here, I don't see a charge in the upper right-hand corner. So that means that it's a 0. So I went from a +2 to a 0. Did I become more positive or did I become more negative? Yeah, I'm going down in number. So I'm becoming more negative. So this is the reduction side. This is going to be the cathode. On the flip side, we should just double check. Does this make sense? Well, the copper, no charge, 0, to a +2. So now I'm going the opposite way, 0 to a +2. I'm gaining positive charges. So this is the oxidation. And this is going to happen at the anode. Now I just have to put these into this format. Now, this is the reactant going into the product for your oxidation half reaction. So here is your starting, and here's your end. And maybe I should just put this as an aqueous, because you should include your states in your little cell notation. So let's go for it. We have oxidation first, so copper, solid. Then I'm going to use that break. Then I'm going to put copper 2+, aqueous. Now, in this case, let's see if we have any more information. They did say that all solute concentrations are 1 molarity. And the 1 molarity, that means that you're in an aqueous solution. Molarities go for aqueous solutions because you have moles divided by a liter, right? A liter of some liquid, right? It's going to be water in this case. So the 1 number goes with the Cu2+. Wouldn't go for the solid, 1 molarity. Now, we're going to double break it out. And now we're going to work on the reduction side. Maybe I'll just put this over here. Reduction side, same exact idea. Start and end. So now I'm going to say PT 2+ aqueous. They did say that all of those concentrations were 1 molarity. So any aqueous that I have is 1 molarity. So I have to include it here, 1M. Break. And then the product would be just a PT solid. And that is it. There's your cell notation. Now, do we need a platinum electrode in this case? You only need a platinum electrode if both of your either oxidation or reduction sides only have aqueous matter in it. But since I have a solid here, we're good to go. And I have a solid here, we're good to go. So we don't need to add any additional inert electrodes. So this is your final answer. Okay, what do you think? Let me know in the comments. Love talking to you guys and love helping you guys out. I hope you're having a great day. Keep studying hard. Good luck on your tests and quizzes. And thank you for being here. Thank you for being part of this community. You guys rock. You guys have been so kind in the comments throughout this whole journey. And I'm so glad that this channel is teaching you not only chemistry, but we also got physics and math videos on the channel too. So thank you. And I'll talk to you soon. Bye-bye.